ಆಫ್ ಆಗ್ಬಿಡ್ತೈತಿ. Yeah. So, hello. Sorry for the delay. I'm Vivek Tiwari, your class instructor for this subject, that is material science and metallurgy. And you know that in this period of COVID-19, we are doing this online classes to complete the portion. And this is in turn some of the series of lectures what we have given. I have given in the material science and metallurgy. We have started with the second unit number second. In that I completed the iron carbon phase diagram and its related things. Then we went ahead with the unit number 3, that is heat treatment of steels. In that we saw the different techniques that are employed to change the properties of materials by heat treatment techniques. Basically we have done that. In the last class we started with the unit number 5, that is non-ferrous engineering materials, and under that we have to study or discuss about 3 things. One is polymers, second one is ceramics, and the third one is composite materials. And in the last class, exactly last class, we have discussed about the composite materials definition, and we have discussed about the application of composite materials. So from that lecture you can understand what is the importance of composite materials in different areas of engineering. For example, you can take the area of aerospace, automobile, medical, then the space, then sports, recreation, etc. There are n number of energy productions, civil constructions, n number of places are there, and the list will just go on if you see, check out the the advantages or the application of composite materials. So we have discussed that, and from that discussion you understand, or you should make a point that composite materials is the new material which is coming up in the present scenario, and it is going to catch up the market very soon. And in fact, metals and alloys is the first important material which was used till now, and the second important material is polymers, and slowly this composite materials is catching up the market also. So composite materials having so much importance in engineering and research areas, we are devoting some time towards it. In the last class we have seen the applications of composite materials. I had stopped at exactly this point. So to summarize the applications of the composite materials, we have seen that composite materials can be used in the automobile sectors, in those particular regions, in aircraft sectors, in sports facilities or sports or recreation requirements, energy development, structural applications, space applications, and even in the human body you can see the usage of composite materials. Of course, in the human body what you see, like the bones and the teeth, are nothing but examples for natural composites. So you should be understanding or remembering that composite materials can be of 2 types. One is called as natural composite and the other one is called as synthetic composite. Natural composite examples, if anybody asks you, you should remember these 2 examples, that is bones and the teeth. These are the 2 examples for naturally occurring composite materials. Other example would be your wood. The wood is also an example of composite material only. So with that discussion we'll go ahead with the further things related to the composite material. I had told you in the last class that if you see a RCC building, that is I had told that RCC is a better representation of a composite material. I had said you that a RCC building, if you see, there will be concrete inside with the TMT bars in it. So I had also told you that the concrete is continuous in nature and it is considered as matrix, while the smaller the TMT rods are called as the reinforcements. This I had mentioned in the last class. So from that discussion you can understand that a composite material will have 2 basic important things in it, or a composite material is comprised of 2 important things. One is the matrix and the other one is reinforcement. What is this matrix and what is this reinforcement, we will try to discuss now. So if you see the matrix, a matrix forms the bulk of the material of the composite material. So if you take a composite material, if I have a composite material and if I want to say what is the if I want to say what is matrix in it and what is reinforcement in it, then one of the indication is that whichever thing is present in large percentage, that will be considered as the matrix. For example, our RCC building, the RCC pillar, the concrete which is more in percentage will be considered as matrix, while the TMT rods are considered as reinforcements. So like that, this is the first sentence. A matrix forms the base bulk of the material. Bulk means majority portion of the composite material will be comprised of matrix. A matrix holds the reinforcements in its place. So what is the function of a matrix? The function of the matrix is to hold the reinforcements in its own place. Okay, so you can you can relate this example with the RCC pillar, what I have already several times said. Okay, when a load is applied on a composite material, the matrix transforms or shares the load with the reinforcement element. So the third the job of the matrix material is to whenever you apply a load on the composite material, that load is to be shared or transformed to the reinforcing material. This is being done by the matrix material. Okay, and then the matrix can be of 3 types. It can be of metal, polymer, or ceramic. The matrix what I am talking about can be of either 3 types. It can be metal, it can be polymer, or it can be ceramic. So based upon what type of matrix the composite is being made up of, the composite is named as matrix, metal matrix composite. Sometimes it is called as polymer matrix composite, or it can also be called a ceramic matrix composite material. Okay, so this is the first important thing what you should remember in the case of composite material. First, you should know the definition of composite material. You should be knowing the applications of composite material. Then you should be knowing that a composite material is made up of two important things. One is a matrix and the other one is reinforcement. Matrix is one which is present in larger percentage. Its function is to transfer the load or share the load with the reinforcement. And second objective of having a matrix is to hold together the reinforcements. Okay. And the matrix can be of metal, polymer or ceramic. Any of these three types it can be, and based upon that you can classify the composite materials as metal matrix composite material, polymer matrix composite material or ceramic matrix composite material. So I have placed a diagram. This is an example of composite material, just a representative. So this black color thing what you can see is called as the matrix, while the gray color things are the reinforcements. Both are joined together at this interface. This is the interface which is separating out this reinforcements and the matrix, and this is the matrix what I want to bring in front of you, that is the black color thing. In fact, in actual situation they will be not so prominently different. Only when you take the help of SEM, I had said, you can see that there is a physical difference between the matrix and the reinforcements. However, just to give you an example or a representation of how reinforcement looks like, we have drawn it in a bigger manner. So that is the function of matrix. While coming to the reinforcement, reinforcement is a material that provides strength to the matrix. So the function of reinforcement is to provide the strength back to the matrix. So together this will form a composite material. Okay, only matrix will not form a composite material, or in other ways only reinforcements will be called as a composite material. Both when combined together, the best of each properties will be highlighted in the final composite material, and that will be called as a composite material. So this is just an example for that. Then reinforcement, what I just spoke or discussed, is an element which is commonly used in any of these following three type of shapes. So if you see the reinforcements, it can be of this type or this type, or the third one which is mentioned as C. This type is called fiber reinforcement, that is called as the particulate reinforcement, and the third one is called as a flake reinforcement. Means here the reinforcement is in the form of long hair like thing, that's called as fibrous. The second one is, it can be in the form of particulate, small spherical balls or components, or it can be in the form of flakes also, the third situation. So all these things can be reinforcements, or reinforcement shape and size, that is morphology of reinforcements can be of any of these types. That's what I want to mean. Or even if it can be in the form of layers also. For example, if you have seen the plywood board, that is made up of reinforcements in the form of layers. So that is also an example of just the morphology of how the reinforcement looks like. Then the next part of discussion is that hence material is considered to be composite material on what basis, that you should understand. So on what basis you can call a material as composite material, and how it is different from alloys. This is a basic question what anybody can ask even if you go for an interview. The basic question they can ask you is, what is the difference between composite material and alloy? They can also ask you that what is composite material definition. Then they can ask you that what are the major constituents of a composite material. These are some of the questions what interviewer can ask you when you go for an job interview. They can even ask you what are the example of natural type of composite materials. So immediately you should be able to tell that it is wood and bones and teeth, like that, right? So on what basis you can call a material as composite material? The criteria are like this. A material is said to be composite material if both the constituents are present in reasonable amount. That means the matrix and the reinforcement should be present in reasonable amount or appreciable amount. It is not that the reinforcement is present in only 1 or 2%, while 98% of the material is made up of your matrix. In such a situation, we cannot consider that whole material as a composite material. For a material to be considered as a composite material, the matrix and the reinforcement both should be present in a very appreciable percentage, at a appreciable percentage. Then the second property is that the property of the composite is noticeably different from each of its constituents. The meaning of this sentence is that the property of the complete composite material should be slightly different or in a better fashion compared to that of each of its constituents, that is matrix and the reinforcement. If the whole composite material shows the same property of that of your matrix, then there is no meaning of adding of reinforcements to it, right? And in other way, the same thing will happen if you have a composite material which shows the same properties as that of the reinforcement, then there is no meaning of adding of this matrix material into it. So a material is to be considered as composite material if it shows a property which is better than that of its individual combining constituents, that is matrix and the reinforcement. This is the meaning of the second sentence. If that doesn't happen, that material will not be considered as a composite material. And the third criteria to be satisfied for a material to be considered as a composite material is that material should be man-made by some physical machines. That means it should not be made by natural way. It should be made by human beings by some physical mixing of matrix and the reinforcement, by some mechanical methods. By that method, if you have got that material, then that material will classify into the composite material. So a material to classify into composite materials, these are the three criteria. Plus, what is another question I had put in front of you, that what is the difference between composite material and alloy? And the difference is that in the case of composite material, you combine matrix and reinforcements in physical manner. They are both combined together in a macroscopic manner. While if the two materials combine together in atomic level, then that will be called as alloys. That is the difference between a composite material and alloy. You should be knowing these things. So with this, we'll go ahead with the next slide. So here I have put this slide to show you the different type or morphologies of the reinforcements. So here I have mentioned the different type of reinforcement morphology. So you can see that first image. Here the reinforcement, first of all you can see that this is a matrix, this is a composite material. The yellow color thing what you can see is the matrix, which is present in more percentage, while the red color things are nothing but the fibers. And by seeing the image, you can imagine that the fibers are moving throughout the length of the matrix. So that is one morphology of the reinforcements could be. The second one is in the form of particulate. This second set of images, this one, you can see that the reinforcements are in the form of spherical or irregular shapes. Okay, so this is nothing but the reinforcements in a particulate manner. The third one is the whiskers. Here there are the fibers present, but it is in chopped form, and small length of fibers are present inside the matrix, and that is called as whiskers reinforcements. The fourth one is the layers. So here the reinforcements can be in the form of complete layer, just like your plywood board, right? So these are some of the morphologies or the shapes that the reinforcements can take inside the matrix. So this slide what I have put just to make you understand that what are the different shapes or the morphology that the reinforcements can take. One thing is very sure, that matrix should be present at higher percentage, reinforcements are present at lower percentages, and the reinforcements can take any of these shapes. It can be fibrous, it can be particulate, it can be whiskers, or it can be in the form of layers also. So this slide is meaning that. Okay, so the different types of the reinforcement morphology. Now coming to the next important thing in the composite materials is the classification of composite materials. So till now, just to recapitulate the things, what we have discussed is, we have discussed about the definition of composite materials, we have discussed the application of composite materials, we have seen what is the matrix, what is the reinforcement, what is the function of the matrix, what is the function of the reinforcements, and we have also seen the different shapes of the reinforcements, the different morphologies or the shapes that the reinforcements can take, that we have discussed. These are all things we have discussed till now. Now let me go ahead with the next topic, that is the classification of composite materials. How do we classify the composite materials? First we'll see the main classification of composite materials, then we'll see how that composite materials is sub-classified. To classify composite materials as a main, composite materials are broadly classified into two types. One is natural composites and the other one is a synthetic composites. Natural composites are nothing but, I have explained you previously also, wood is an example for this, the human bone are there, the human teeth are there. These are all example of the naturally occurring composite materials. Then the synthetic composite materials are the one which are man-made. As I said, they are man-made by some physical joining or physical mixing of 2 or 3 components. That is our synthetic composite materials. And synthetic composite materials can be further classified into 3 types. That is based upon the matrix what it is having. It can be classified as ceramic matrix composite, it is called as CMC. It can be polymer matrix composite, which is called as PMC, and it can be metal matrix composite, which is called as MMC. So based upon the type of matrix what the composite material is made up of, it can be classified into 3 types. It is ceramic, polymer, or metal matrix composite material. The same thing is depicted over in this graph. So this is ceramic, metal and polymer all together also can form a composite material. So this is just an representation of that the composite metals can be broadly classified into two types. One is natural and the other one is synthetic or artificial. Under synthetic there are three types, that is PMC, CMC and MMCs. Then if you see again this synthetic type of composite material can be again classified based upon the type of the reinforcement what is present in it. It is not only based upon the type of matrix what it is having, it can also be classified based upon the type of reinforcement what it is having. Not only that, its morphology also can help us to distinguish the different type of reinforcement composite materials also. So with that point of view, we'll go ahead with one more classification manner. It is in this way. So composite materials can be classified based upon the matrix what it is having as polymer, ceramic or metal. Right? So polymer, ceramic and metal. So composite material which is having a matrix as metal is called as metal matrix composite material. A composite material which is having a matrix as polymer will be called as polymer matrix composite material. The one which has ceramic will be called as ceramic composite material, yes, CMCs. Now with this, can you tell me what will be the application? I will just ask a question to you all which is from just a general knowledge. If I want to make use of a composite material for high temperature application, which is the one which you will be selecting for? Yes, you will be going for ceramic matrix composite material because ceramics can sustain high temperature applications, correct? So you should go for ceramic matrix composite materials. In the other same way, if I want to go for a composite material for low temperature applications, which is the one which you will be selecting or going for? It will be PMCs, that is polymer matrix composite material, because polymers can take up only low temperature conditions. Okay, so like that you can classify the composite materials broadly on the type of matrix what they are having, that is polymer, ceramic and metal, right? In the same manner, the type of reinforcement what it is having and its morphology will also be help us, or shape will help us to differentiate the composite material. The orientation and the shape of the reinforcements can be continuous, it can be short fibers, it can be whiskers, or it can be particulates also. So the last figure what we have seen, particulates means the reinforcements can be in the form of small dots. It can be whiskers, small chopped fibers. It can be continuous fibers like that, or it can be short fibers also. So based upon the orientation and the shape of the reinforcements, you can classify the composite metals. Not only that, you can classify the composite metals based upon the chemical nature of the reinforcements also. Whether the reinforcement is in the form of oxide, whether it is in the form of carbide, whether it is in the form of nitride, all those things differentiate or classify the composite metal. I'll put in front of you a very simple example that n number of composite metals are coming up day to day life. We'll just see two examples and how do we name those composite metals we'll see. For example, nowadays one example is coming up as GFRP. So this is glass fiber reinforced plastics. Glass fiber reinforced plastics. So now with this definition what I have given to you about GFRP, you should be able to tell me which is the one which is matrix here and which is the one which is the reinforcement over here. I'll again repeat it. It is glass fiber reinforced plastics. So it means that the plastics is the matrix and in which glass fibers are reinforced. So here the plastics is nothing but our matrix which is present in large quantity, while glass fiber is nothing but the reinforcement. So that's how you name the polymer composite materials. In other way, if you are trying to make a matrix composite material made up of aluminum plus some kind of nitrates into it, for example silicon carbide, not nitrates, silicon carbide, then you will be definitely using aluminum at a larger percentage and you will be adding silicon carbide into it in a smaller percentage, and this will classify or will be called as an MMC, that is metal matrix composite metal, because the matrix which is present in larger quantity is metal, aluminum, while silicon carbide is added to it. It is an example for MMC. So just like that, you can say the different type of composite materials which we are coming up in the day-to-day life can classify into one of the types what we have just discussed. So broadly, composite materials can be classified into two types, synthetic and natural. Natural can be classified again based upon the type of matrix what it is having and the type of shape and orientation of the reinforcement what it is having. So this is the classification of composite material. It is an example, important slide. Okay, please remember this. Now I have just put a slide over here. This is an example of a composite material. The image is taken from SEM, that is scanning electron microscopy. Here you can see two phases. The first phase is this one, gray color, while the other one is this blue color, right? Blue color. Now you should be able to tell me which is matrix and which is reinforcement. Which is the phase matrix and which is the reinforcement. Have a thought about it. Okay, so as you are all thinking, it is correct. The gray color what you are thinking or you are seeing is continuous in manner. It is more in percentage, so this should be the matrix, while this blue color thing what you are seeing are lesser in number and they are nothing but the reinforcement. So this is just an example, or till here I have been slowly moving into the composite materials. I have defined you the composite materials. I have shown you where it is being applied. I have shown you what is the important in a composite material and how to identify which is a composite material and an alloy, or which is not a composite material, how to identify that we have discussed. Then how to classify the composite material, if it is classifying into a composite material, how to classify it, whether it is an MMC, whether it is a PMC, whether it is a CMC, that things we have discussed, right? Now going ahead with the processing of composite materials, this is the last part under the composite material. So you should be knowing the we can or process the composite material. So making of composite materials involves techniques. We are going to discuss such 4 techniques for your UG level. The first one is hand layup process, the second one is the spray up process, the third one is filament process, and the fourth one is bag molding process. So these are the 4 type of processes what we are going to learn as per your syllabus as the methods of processing of composite materials. So coming to the first one, that is hand layup process. The hand layup process is like this. This hand layup process is the most simplest form of making the composite material. So if you want to make composite material, the most simplest way by which you can make a composite material is this hand layup process. And again, the word hand layup will help you to understand what the meaning is. So whenever you come across such easy words, you should relate it with the process what we are just going to explain. So hand layup, just like laying. So if you want to make a building, what you do, you lay up the bricks. Just like that, if you are making a composite material by hand layup process, you are going to lay the matrix and the reinforcements one above the other and get the composite material. So the word hand layup will tell you about the process also. Okay, so this hand layup process is also called as the bucket and brush method. It's called as bucket and the brush method. The bucket is in the form of mold and the brush is used to make the process or make the composite materials. I will explain you that in detail. So it's just now you remember that it's called as bucket and brush method, and it is the most simple and the most oldest method used to produce a composite material. As I told earlier, it is the most simple and the oldest method to make composite material. It is widely used too, so it is widely used for making such composite material, and it is also called as a poor man's method. So if a poor man want to develop composite materials, he can make use of this technique, right? And it is the simple and economical method. It can be as big as possible. So one of the advantage of this hand layup process is that you can make as big as composite material what you wish for. It is not that you need to make you can make only a small composite material. There is no restrictions on the size of the composite material what you can make by this method, right? And it is an open mold process. I'll explain you later when I explain you the process. You will see that the mold is being used and the mold is open to the environment. That's why it's called as open mold process. Now I'll explain you the method by which this or the process of making a composite by this hand layup process. So this one what you can see is the mold. This is the mold. It is open to the atmosphere, so it's called as open mold process. Here what you do is that you first of all put a releasing agent. I'll tell you why that releasing agent is being put, and then you go on adding the matrix and the reinforcements on it, and then you make use of a roller and push or apply pressure on that applied matrix and the reinforcement so that air particles and all come out. And after that you allow it to cure, and then after curing you will allow it to cure, you allow it to harden up or allow it to dry, and then you will get a structure like this. So the front view of this boat hull is like this, while the side view is like this. This one is prepared using this mold or by the hand layup process. So this is just an explanation of how the hand layer process goes. The next figure will explain you the things in detail. So here is the schematic diagram of the hand layer process again. So here we make use of the open mold, which is open to the atmosphere. What we do is that first we apply a releasing agent. This release agent, why you apply is that so that when the final composite material is being made, it can be removed out from the mold very easily. So for that reason, you put this releasing agent here. Then what you do is that you put the reinforcement. Reinforcement in the form of, usually it is put in the form of cloth, in the form of matrix cloth, or in the form of cloth it is being put. So that's the reinforcement, and then we put the matrix in the form of resin. So resin is being put. Once you have put, this is the resin, right? It's being put over here, and below there is a reinforcement, and below there is a releasing agent. So when these three things are being put, the next thing is to use the roller and put pressure on this thing what you have applied to get the desired thickness, plus so that the air or the air which was entrapped or the gas which is entrapped inside comes out. For that reason you have to do the pressurized rolling on the mold, and after doing this process for some 3, 4, 5, 9 times, like how much desired thickness you want at that for that number of times you need to do it. After you do that, you take the whole component and allow it to dry for some time. That's called as curing. You cannot keep it inside an oven because the size of your mold will be quite high. So if the size of the mold is very high, it is being kept in the open environment to cool down or cure, and then you remove this composite material out of it and you use it. So while removing, this release agent will help you to easily withdraw that that composite material out of the mold. So this is the the construction and working of the making of the hand layer process. Okay, the same thing I have put it in the words. Mold is made up of wood, metal or composite materials is prepared to suit the part to be produced. So the mold can be made up of wood, it can be made up of metal, like that. The mold surface is given a coating of release agent like silicone, polyvinyl alcohol or wax, non-sticking to the part of the mold and easily releasable. So why you apply that releasing agent? So that at the end the composite material can be withdrawn very easily. Only that reason is there for using of releasing agent. Then the gel coat is applied to form a protective layer on the component. Alternate layers of matrix and reinforcements are laid till the desired thickness is reached. So what you do, once you apply the releasing agent, then you apply the matrix, then you apply the resin, then again a matrix, then again a resin, then matrix, resin, like that you go on applying. Then you use a roller and move your roller on it so that the entrapped gas comes out and allow it to cure. Each reinforcement layer is compacted using a roller so that the wetting of the resin with the reinforcement take place. So that one thing is to remove the air from that composite material, and other one is that wetting should happen, that matrix and the reinforcement should combine together, wet each other, and the desired thickness should be achieved. For that reason you use the roller, and the part is left in the mold for curing, that means drying or hardening. After that you remove that composite material out of it. Now this is an example of boat hull. I'm sorry, here I'll show you. Yes, so here it is, you can see this one. This is an example of a boat hull. Okay, it's not coming over here. Okay. Yes, so you can see this is the type of boat hull, and you can see that this is the mold, and on which he is producing that or making that using of he is making use of that hand layer process to create that composite material. So what he is doing, he is basically moving the rollers on that matrix as well as the reinforcement and getting the composite material. So this is just an example, and boat hull, wind turbine blades, etc. are made up of this type. The curing will take time suitably only for low. Yeah, one of the disadvantage of this type of technique is that two disadvantages are there for this technique, that is the hand layer process. The first basic disadvantage for this hand layer process is that it will require curing. That means you have, once you have laid the matrix and the reinforcements, you should allow that whole setup to cure or dry for probably 1 day or 2 days of time. Sometimes it goes even for 3 or 4 days of time. So till that period of time you have to wait down, and that is can be considered as a disadvantage of this technique. And the second disadvantage of this technique is that it is suitable only for low volume production. Low volume of production means you can imagine that you are making a boat hull out of this technique. So only one boat hull can be made out of this technique at a particular instant of time. You cannot 10 pieces or 20 pieces at a go. So one set of people should start working on your one component and should work on it till the complete thing is being done. So that's why it is considered as a disadvantageous fact about this technique, and it is suitable only for low volume productions. Only for 1 or 2 volume or production pieces, if you want, you can go for this technique. Now I'll show you a video for this one, so that you can understand this technique more betterly in a more better manner. So here it is. Yeah, here it is. So this video will show you how this composite material is being made by hand lab process. So you can see this. I hope it is clear. This is the resin part, while right, and this is the mold. This is the mold on which he is putting the resin. So this is the resin, and the reinforcement he has already put in the form of a mat, and now he is making use of a roller. You can see this. This is the roller. He is rolling on it. This is called as the hand layer process. As simple as it is, it's called as hand layer process. Now he puts the second layer of reinforcement, yes, on the first one, and he again puts the resin, which is the matrix. Then he wets that matrix, and the reinforcement is wetted using the matrix, that is the resin, and then he makes use of the roller. Then he puts a third layer of the reinforcement. You can see this. So this is a video just to explain you the method of hand layer process. So I hope you have understood that what is this hand layer process. Now we will go ahead with the next type of process, which is called as here now it comes. This is called as the hand layer process, an example. Now we'll go with the next usual method of making the composite material, which is called as a spray up process. Okay, this spray up process is the same like that of the hand layer process, but with only the difference that there is a usage of spray gun in this case. So in the case of your hand layer process, you put that the matrix and the reinforcement with the help of our hand, but here we make use of a spray gun. That will be shown when I show you the schematic diagram. So the process is same like hand layer process, with the only difference that here a spray gun is used to apply the reinforcement. It is also an open mold process. Here also you will see that the mold is open to the environment. That's why it's called as open mold. It's also considered as an open mold process, and it is an extension of hand layer process, just an extension. Then advantage of this process is that a uniform thickness of composite is obtained. So here the advantage of using this technique compared to our hand layer process is that here you will be getting a uniform thickness of the composite material, and even large volume productions are possible. So here, unlike our hand layer process, that when you can make only 1 or 2 products, here you can make n number of products quickly. Not quickly mean the same, you can produce it in a large volume. That is the advantage of this technique. This technique is called as spray layer process. Now this one, what the image what you can see on the slide is the schematic diagram of the spray layer process. So here there is an open mold. This is an open mold. Again, since it is open, this process is also considered as an open mold process. Here what you do is that you apply the releasing agent just like the previous case, then you put the resin, then you put the reinforcement. But this resin and the reinforcements are being deposited with the help of this spray gun. This is the spray gun. It has 2 inputs. One input is this polymer fiber, which is nothing but the reinforcement, while the resin supply, this will be supplying our matrix component. So both this resin and the fibers will be combined over here with the help of a catalyst. A catalyst is one which will harden both of them, and then it will spray it out on the open mold. So unlike the hand layer process, here the reinforcement as well as the matrix comes in the spray gun, and it is sprayed out using this one, and it is being sprayed on the mold. And then there is a roller again, which is being rolled on the surface of this deposited matrix and the reinforcement, so that the entrapped gas comes out, and it is being allowed to cure for certain duration of time, and then you will get the composite material out. So the function of, the working of this technique and the previous technique is the same. Only the difference is that in that condition you put by hand, while here you make use of a spray gun to deposit the reinforcement and the resin. What is the advantage? The advantage is that because of the mechanized spray gun what you make use, you get a uniform thickness of the resin and the matrix in this case. That is the advantage of using this type of technique called as a spray layer process. So this is that. So spray release gel is applied on the mold surface to facilitate easy removal of the component from the mold. That means the release agent what we are using here, again the meaning of that or the reason for that is so that at the later stage composite material can be removed out very easily. Thin plastic sheets can also be used. So unless otherwise, then other than the releasing agent, you can make use of even a plastic sheet. Also is possible. Then a spray gun is used to spray the pressurized resin, catalyst and reinforcement in the form of chopped fibers. So the wire which is coming out, here, this one is also been chopped over here. In this spray gun, it is being chopped, and it is mixed with the resin what's coming up. Both will be mixed together and sprayed out. That is the meaning of this sentence. And then the roller is used rolled over the sprayed material to remove the air trapped inside the layups. So that roller is used basically to remove the air which is trapped inside the layups, and curing is done at room temperature. So curing you can do at room temperature so that hardening happens and you will get the mold. So composite metal. So this is an example of that spray process. You can see that this is the person who is doing this process, that is spray process. He is holding a gun. It is having some inlets, two inlets. One is inlet for the the resin. Second one is the polymer fiber which is coming, and then there will be a catalyst on it which will combine this both and spray it out on the open mold. So this is the example for that. Now these are the two processes which I have to explain you all. Now what I will do is that I will show you the video for this one, right? The spray process. Just a second.
Now we will cut certain sections. See, we have cut a bit.
Yes, so you can see this one. Yes, so you can see this one. This is the manufacturing of a boat hull by spray layer process. So it's being shown over here. The laminates are being put. Such a number of videos are available for these processes what I have explained on YouTube. You can make use of that. So this is the cutting of that wood material. This is the CAD modeling on the computer. This is the manufacturing stages. So this is the one. This is the one what I was telling about. You can see this one. So here, this is the process what I was talking about. Here you can see the spray gun being held, and you can see that the fiber and the reinforcements both are being sprayed on the mold. So you can see this. This is the resin, the reinforcement in the form of fibers. So you can see that it is coming from backside. So you can see this rovings and all. So from here, the reinforcements are coming while he is putting the spray. So you can see this. This is the spray process. So once spray process is being done, rolling is being done. So this is how the rolling is done. You can see this. So this technique is called as the spray up technique. Spray up process of making the composite material. see this, right? Yes. So like this it happens, and then n number of things are there. Then you get the final thing, right? So here we complete with the spray up process about making the composite material. So to brief about what we have done till now, we have discussed about the composite materials definition. We have seen how we classify or the importance or the application of composite materials. We have seen how we classify the composite materials, what are the important things involved in a composite material, that is matrix and the reinforcement, what is the function of each of those, that is matrix and the reinforcements. We have seen when does a material classify as composite material. We have seen how do we classify the composite materials. We have seen how do we process the composite materials, and in particularly we have seen two techniques. One is the hand lay process and the other one is the spray process. In the case of hand lay process, we put the matrix and the reinforcements by hand, use a roller and get the desired thickness. In the case of spray process, we put the same resin or the matrix and the reinforcements, we are using a spray gun, put it on the mold, allow it to cure, use a roller to get the desired thickness and remove it out from the mold to get the final composite material. In the next class, we will be discussing the back molding process for making the composite material. Thank you.